code on this computer. Okay, so let me just have a quick look at what other things were in the chat beforehand. Okay, sort of. All specific paths. Yes, Alex. I guess it makes sense to repress assignment details. I'm a little surprised that the assignments were that traumatic, but I also, yeah. Yeah, in terms of depending on if you had me for 1400 or not, and now you know you didn't. Link to the exam page, or yeah, we have to get it yourself. Yes, considering the time. The idea is if you didn't do squat all term and then you go to the exam, I want you to have it to take you longer. If you did the work throughout the term, you should go faster. If you're giving it to some other person online and paying them $20 or whatever the case is, I want it to take more than 3 hours, right? That's where we're aiming, or at least it should slow them down or make it error prone or whatever the case is. If it's my friend is using it and I'm doing the same exam, I want you to have different versions of the exam or slightly different questions. So you have to actually solve the exam all over again from scratch, not just copy and paste. The only ways we can do for online exams is to and try and reduce cheating is to put these they're tripping hazards, absolutely, but it's unfortunately what we're resigned to, right? On a paper exam, I could say, okay, well, I know they're not going to just steal the linked list code from online. I wouldn't ask for reproduce a linked list. You've seen it, you could have memorized it, but I can ask questions that are less, I just grabbed this code from online. It's also less likely for someone to steal the code from other people or ask for outside help. Format similar to the mock exam provided or completely different. I can never remember if this mock exam is the 1400 mock, my 1400 mock exam and my 2400 mock exam. One of them has no real questions. It's like, do you like stuff? Yes. It was purely for letting people play around with stuff. It will essentially be open book. I got in quote unquote trouble for that in the past. So I reported someone for academic integrity violations for the exam, and they said, well, you didn't say we couldn't look up the answers online and just copy and paste their code. And I was like, yeah, the code got to be your own. Now, you can look at other people's code for inspiration. You can look up things, how to call that particular function. That's fine. Great. Go for it. But if you're copying like a block of code, yeah, you're doing something wrong. If it matters, but I feel like writing down on paper is easier than nervously typing. And I completely agree, Sarah. Yeah. I like paper exams. Some people love electronic exams. I've actually heard some people do the reverse. I like paper exams just because I know what, we're sort of getting. But the problem with the paper exam is if you're used to typing all the time and you try and do your exam with a pen, you didn't practice using a pen for your exam. And honest to God, it actually makes a difference to the point that when you do a Google interview, one of the biggest things that they make people do or suggest people do is to buy a whiteboard and practice doing Google exam questions on a whiteboard. Because what you want is there is no separation between there. You don't want state dependent learning, what it's called, right? If you lose your keys while you're drunk, you got to get drunk again to find your keys. Honest to God, I'm not suggesting drinking, but it's what state dependent learning is, what that's all about. If you're extremely loaded up on caffeine while studying for an exam, you should be loaded up on caffeine for taking the exam as well. You want the same situation where you're learning, because your memory is associative. The way you learn, you want the same situation as when you're doing your exam. You do it if you do your studying in your PJs, do your exam in your PJs, essentially. Okay, so yes, I completely agree. It is a crap situation all around. I apologize, but there's no workaround. Find writing down the paper easier. Pseudocode. And yeah, again, if you don't have code that compiles, I want to keep on emphasizing this because I know some people get Visual Studio out, they have some error in their code, and then they'll spend 40 minutes trying to debug or make sure it works perfectly. And you're like, no, get it done, right? type it up in Visual Studio, throw it onto your exam, move on to the next question. If you have a minor bug, you lose a couple points. You got a major, like the thing makes no sense, you hard coded all your values, yeah, it's crappy. But if your code is close enough, you should get most of the points, if not all the points. Right? That's what we're looking for. We're not looking for, did it compile correctly, and do we run the proper number of tests and stuff? It's an exam. It's not expected to be an assignment. Would probably there's a couple points. Yep. So like a place to put our drafts. What would you consider a draft? You can copy and paste your code that you're working on, dump it into either the big text box that will be on all the long questions, or you can attach the file and just attach more and more files afterwards. Call them version 1, version 2. That's fine. And we just grade that. So if you run out of time, you got the other version up there. Yeah, the CUlearn text editor is the worst. Yeah, I'll give VI the worst, but yeah, it's pretty terrible. If you don't know what VI is, be thankful. So yeah, you can actually, all of the long questions, unless it involves you writing up words like what are the errors in this code. If it's just write this function, you should be able to copy and paste, like just save your file in for Visual Studio and attach your file on your exam. Oh, why didn't you have to? I would actually open up Visual Studio, have it open from the very beginning with a project, and just start throwing files in there. Yep, Notepad++ is fine if you have it set up. Visual Studio Community is faster and fairly short as well. Yeah, have Visual Studio open, right? I have a version of it open right now. I think you're seeing it right now. And it's me. I'll go into this thing and I'll just, okay, I'm going to go to tester. I'm going to throw in some weird function. And here we go. Int foo, not food, blah, blah, blah. And I'm going to do a bunch of stuff. And I can just throw it in there, right? Afterwards, it doesn't need to compile. I just I can copy and paste it over, or save the file, save it out to the separate file, whatever works for you. Part of this, and it's an unfortunate part of this kind of format, is you're right. If it was on paper, you could just write something on the paper. We're going to give you partial credit. We'll give you partial credit otherwise, but people want to write things perfectly this way. And I want doodles a lot of the time, right? And people want it, to make sure it compiles. So if you are in a rush, just type a bunch of stuff in here, copy and paste, or type a bunch of stuff, save the file. Okay. Yeah, you can copy the question into Visual Studio. I get a little bit of a tricky jerk sometimes, if you hadn't noticed, like the find the error, it's an image. It's an image, so you can't just copy the code over, run it, and then go like, oh, it does this, right? It's meant to be, can I trace through code? Oh, there's an error there, there's an error there. That comes with practice. Again, all of this is with, if you've been doing the assignments, which I'm pretty sure all of you have been doing, you're doing the assignments, you will have that practice. Even if you don't think you have that practice, you'll be amazed at how much you've accomplished this term. Yeah, but you don't need to technically. Oh yeah, it would yell at you. I will give you that. You don't need technically a main method. You don't even need to try to compile it. It'll just give you the auto formatting. It'll give you the closing and opening parentheses. It'll give you the indentation for free. But it will give you underlined error messages. You are absolutely correct on that. And so it's you can actually turn off the errors, by the way, if you wanted to. I think it's in your yeah, because when I was doing the error message, to take a photo of it, I found out how to turn off the error messages, because I had to make sure you didn't get red underlines on all the errors. Otherwise, it's easy, like that one, that one, that one. So I think it's customize or options, and then you can, it's in there. Prepare that in advance if you want to make sure you don't see the error messages. Although you could, right? If we ask you to write a class, Well, if it's an entire class, like one of the questions on the last exam was, why not have it almost right? Right? It's another class. I go over here, I add a class, and I just I put an entire class in there, and I can have it compiled correctly or almost correctly, and then pass those files in. A lot of this is just practice to make sure that you're feeling comfortable with doing this sort of thing. And that's why the benefits of taking last term, they just had a final exam online. That was it. You guys have had at least 2 exposures to these online exams before we got here. So now that you know what the format is, now that you know how I tend to ask questions, you know exactly hopefully you know exactly what kind of crap I'm going to pull on you, right? It's going to be things like really nasty multiple choice questions. And I apologize. I always get a little tricky. They're not supposed to be, multiple choice is not meant to be like, hey, a bunch of give me 20 points. Long answer questions, you can expect us to be more generous with the grading, especially if you almost get it right. But I had one student where almost got it right, but the syntax was wrong, but the logic was dead on. So he or she got a lot of points as a result. But if you're just guessing random syntax and it makes no sense and there's no curly braces or anything, yes, right? If you need to throw in pseudocode, that's fine. Final exam yet? I've made it, so I should hopefully know that. Does it matter how many multiple choice questions there are? I've always found that fascinating. I will say it's not 100% multiple choice questions. I'm not sure if I'm happy or sad. I remember back in the day, I would make the only long answer question, and then people would say, "Please give us multiple choice questions." I'm like, "You don't want my multiple choice question?" Yes, we do. At least I get the reverse now. It will not be the multiple choice. If they're, I would say you're probably going to max out at between third. Absolute maximum would ever be 40% of an exam. I do not believe in like one of those 100% multiple choice questions exams, and they are scary because you're like, I'm committed to one answer, and I feel like there's 2 that could work here. So I don't tend to make more than, it's normally anywhere between the 10 and 40% range. In that range, that's a huge range, I know, but I tend to like longer questions whenever possible because they show more knowledge, right? Rather than, the reason we have multiple choice is I had one exam a while ago where there were people that got like 2% on the exam because they didn't know anything about coding whatsoever and couldn't write anything on any question on the exam. Multiple choice, they can just guess, right? They're getting 25% on that part. Right? So you can at least boost the lower end's average, but it reduces the higher end's average, unfortunately, as well. No, the multiple choice questions will not be partially correct. The reason it's not partially correct. It is if you got it wrong on the quizzes are meant to be based off of doing quizzes in class. And it's a philosophical thing. Quizzes in class, what I want people to do is when you're first learning something, you should feel free and be able to screw up. So if you do, if you're in my 1400 class, you've seen this before. If you're in my DS2100 class, you've seen this before. When you're just learning something, I want you to be able to play around with it. And there's a right and a wrong answer, but I don't want you to feel like, oh my God, I got it wrong. So when we do in-class quizzes, let's say, it would be about most of its 50% of its participation. And that's where that partial mark is. You participated, you did the quiz while you're learning. The exam is summative, as in I'm at the end of the day, I'm claiming that I know my stuff enough to pass this course. And therefore the evaluation is whether you're right or wrong, not whether you attempted it, but whether you're right or wrong. It's at the end when you've already done all the work. You should be getting it right by that point in time. But when you're first learning, you're expecting to fall down. You're expecting to screw it up. That's okay. That's why we do partial marks for just attempting it. So I don't think people actually read all this chat window. So I want to make sure if there are other points in there. So can I ask, while I can more than happy to answer other questions about the exam, about how we do various things. Um, I wouldn't say it's the base of all the questions. I was using linked lists for a very particular reason, and I think it may have freaked people out or not. And there's logically, it made perfect sense. It's just it scared people. So our linked list, the main topic or the base of all questions, linked lists were meant as a recurring theme to motivate what we're doing. So it is, here's a linked list. We'll make one in a structure. Okay, now that we have objects, let's see linked lists again. Oh, you can see now you can compare what it was like before and what it looks like now. Oh, why do we use objects? Because objects allow me to just call the linked list knows about itself and it manipulates itself, and you can add elements to it and it knows how to digest or take in a new element. Versus a structure, you have to pass in the linked list each time. Okay, now that I have this, now let's look at inheritance. We'll change the linked list and make a more advanced version of the linked list. Okay, we can revisit the same code again. Okay, now we'll look at polymorphism to make sure that we're calling the right function when we call it. Or we have two functions with the same name. Which one do we call? Based on the parameters. Okay, we can revisit. We can look at this topic from something that should be more familiar because we've done linked lists a bunch of times already in the class. When we get to templates, we can revisit linked lists again because we've done it a bunch of times already in this class. Rather than you introducing a brand new topic, it's just the same topic from different perspectives, so you know how it's changed over time. I can't think of a good analogy. There's other analogies that are floating in my mind, but I'm trying to think of what a good analogy would be. When every time they remake a movie or a play or something like that into a new era, they put their own modern spin on it, and you can tell the era, the date, based off of how things look. When you make an engineering building as an architect, it's going to have a certain characteristics all the time, but you can tell how engineering buildings change over time, and that tells you how the style has changed over time because they have the same basic format, but it'll look a bit different each time. Right? It's revisiting it over and over again to show how things have changed, the delta, how this data structure has changed when I introduce objects, when I introduce inheritance, when I introduce templates. And it's meant to just be a callback because a linked list is a relatively simple data structure compared to other things. And so we can play with that concept over and over again. Versus if I just tell you what an object is, you're like, what the hell? I don't know what that means. So if you want an example, linked list would be an example of it. I have it up here. So let's have a quick gander. This is me making a templated linked list. I give this there's one of the later videos that I've recorded. This is the simplified version of a linked list that I made. I got rid of the doubly linked list stuff. I got rid of all because it was getting really out of hand. So all I have is a linked list, which has a linked list node. So each of this linked list has just a whole bunch of nodes that are strung together, like Christmas tree lights, right? One connects to the next, to the next, to the next, or a train. Okay, so the whole thing is a linked list, like these are my Christmas tree lights, but each light is its own, like strung one after the other. Okay, I might want to make a linked list that is full of string nodes or string data, my own data type that I wanted to make up. And I may want to make a linked list that stores a whole bunch of integers. That would be fine. Maybe I want a linked list that stores a whole bunch of another thing. As long as this thing fits a particular template that we have, as long as it fits in this sort of what kind of I would think of a good example. There's lots of examples of this, but what makes a university student? Now, that's probably not a good example, right? But what makes a university student? There are certain things that they would have in common. Now, they're not all the same. Clearly, different universities are going to have different standards, different, different academic abilities, even the different ages, different genders, all sorts of different things amongst universities. There are some things that they will have in common, presumably. They're human. for example. I don't think there's many universities for, gerbils or snakes or whatever the case is. So if you have this thing, like if I want to say this is a list of university students and only will take in university students, well, anything that matches the criteria for university students can be fit in there. That's what a templated class is all about. It takes in data of a particular type. It could be almost any type, or it could be something very specific, as in it has to make sure that you can draw it, right? I can make a linked list that only takes paint shapes. By the way, paint shapes were something that we did in class as well. Make sure you feel comfortable with those, right? You don't have to memorize things, but what the heck was going on? We had events, we had a model view controller architecture, right? So that your separation of concerns, that when you paint something, you don't worry about how the model works. When you paint something, you don't worry about the mouse. You separate their different actions. Okay. But a linked list is just going to take in data of a particular type. In this case, we can actually even look at what that type, what it needs to implement. So let me try and make this, and we'll hopefully get an error. And we're going to put in a string and LL break. It's going to break. That's why I'm saying LL break. What the heck? Why is it not allowing it? Simple version of linked list. Okay. Oh, it's undefined. That doesn't work as well. All right. Let's include string. Hopefully it may or may not break. Let's find out. Why is it not working? Ah, standard definition. Okay. Is that going to work? Let's find out. Nope. Why? And it tells you right here. Get value is not a member of the string class. What I know about how I implemented linked list is my linked list class. It's all in here. So we're saying it's get values there, get the thing that's missing. Let's have a look. Is being used. Let's see here. It may not be in this one. It might be in the next one. Linked list node. Gotta move that over. Okay. There you go. I have a call to get data for whatever type of data I have in my linked list. If I didn't have that call, I wouldn't need a function called get value. I wouldn't need a function that get value to make sure that this thing works. If it just worked naturally, then I wouldn't have, I could store strings in this thing. But because my linked list node calls this function called get value, and it doesn't know what data is, it just says it's some data type T, something happens over there. But whatever template I have in this thing, whatever type of data I store in here, it has to have some function called get value. Why? Because I'm calling a function called get value. And so when I go to compile it and I try and make a linked list that stores strings, it says, hey, strings, can you call a function? Do you have a function called get value? And he goes, nope. And he goes, well, you're not coming in this linked list then. And you get an error. It figures out if the thing is acceptable when you go to compile, which is weird. Something to play around with at least. So get value is here. Let's see if I have another instance of get value in here. Oh, no. Let's see if I can get rid of this. And I'm just going to do this. All right, let's see if this thing lets me compile. Foo must return a value. I don't want foo anymore. Okay, let's get rid of that. My linked list will take in everything, including strings now. Now, there might be other things that linked lists need to deal with. Here's linked list node again. I want to see things that involve, data dot something or other. Data dot toString. I also need a function that called toString. The weird thing is strings have a function called toString, and therefore strings are allowed. If I pass in an integer though, nope, can't do it. If I pass in some other kind of object and it doesn't implement toString, no, I can't put it in my linked list. So every single function that I have in here, as long as the object being stored in my linked list, as long as the templated class has that function, you're good. You can throw in whatever you want as long as it has, in this case, toString and get value. If I put get value back in, right? I have something called toString that needs to be implemented. I don't know what the data is, but I know that whatever function, whatever class that's in here, as long as it has a function called toString, it's allowed. Is that making some sense? And so this is a kind of, we were talking about templated things beforehand. So I just wanted to, again, bring up templated classes in the context of a linked list. So I was going to, if it's okay with you guys, I'm going to put this back. And we're going, what I'm going to do is I'm going to get rid of that string. Oh, by the way, yeah, if you had noticed, we have something crazy pants in here. Let's get rid of the string here. Get back to what we had before. Notice that with a linked list, or with a templated class, and I could not believe this when I first discovered this. I was like, what kind of crazy language is this? With a templated class, all the code, when I include something, I have to include all the code all at once, meaning that at least, unless there's another way, I don't know how to do it. I'm putting everything, all the functions themselves, in the header file, which would be absolute no otherwise. I want to make one little change in this header file somewhere. I got to recompile my entire project all over again. Slow as heck. You never want to change your header file unless you have to, right? And here I am, every time I make even the slightest change, I got to recompile the whole darn thing. That's why we have header files, essentially, is to reduce the amount of time it takes to compile this thing. So I have all my code, instead of just saying I have a function called get previous, here is get previous. It's right in the header file. Okay, so that is a linked list. Did you guys want, let's see if I can unpack something, if there's anything here. So we talked about linked lists. So here would be, as I said, one of the exam questions could be write a queue using a linked list, the linked list that we already have. So I'm going to make, let's say, not even a templated queue. I'm just going to make a queue, and then if I need to template it, I'm going to, roll it back. Is template of a template important? Do we have a template of a template? But yes, it can be important. So this is where it gets a bit insane. If I have a template of a template and doing all sorts of like pointer to a pointer, that sort of, when you get into that territory, it hurts your brain, and you get into that territory and you don't want to get there. And it's, so in this case, I have a linked list node that has a template. That's easier to get your head around. Template of a template means that it just gets hard to deal with. Instead you would say, a template S instead of T, and then S would happen to have a template as well, et cetera, et cetera. You spend hours trying to debug that thing. So let's do something quick here. So what does a queue need? Oh, well, let's make a queue. So I'm going to make a new class, and we're going to break things because I know I'm going to have to change my linked list, but I've already marked it down for what I'm going to need to change. But I'm going to make a brand new class, and I don't want to call it Q because everyone calls it Q. Q2400, we can call it LLQ. Let's call it Q2400. Okay, this is the class I'm going to make. Oh, so what does this have inside of it? Well, what I'm going to make it have inside of it is so private, I'm going to have a linked list, and I can store some type of data in there. Now, I could put type of data T, but I'm not going to do that right now. I'm going to say it always has an LL data inside of it. Why? Because I don't want to have to figure that out. And we'll call it list. Okay. What else do I need? So what does a queue have? Well, Q2400 has probably will have some kind of constructor and a destructor. Let's say it doesn't always have those. If I don't call new at all inside the constructor, I don't need a destructor at all. Or if I don't need to clean things up afterwards, I don't need a destructor at all. All right. And then what else do I have? What goes in a queue? What, pop it on the chat or say it out loud. What does a queue need? Maybe you don't remember the terms, but all right, let's see what you got. All right. Pop. Okay. Yep. Let me see here. And templates, by the way, just to answer Sarah's question, templates are not inefficient, as in you will actually generate new classes for every different type of data you store in a template. And so it's just as fast as the other kind. It's just really damn hard to get your head around. AJ, it's a very nice attempt. Pop and push is a stack. Pop and push, as in you push down the stack, you pop off the top of the stack, like a Pez dispenser, if you know what those are. NQ, you can also push. I normally say DQ and NQ, as in I remove something, I put something on there. To NQ, as in put it in, DQ to remove it. There'll be different terms. Some people will say pop, front, push, back, or something like that. But NQ and DQ is fairly standard terms. Very long-winded terms, but fairly standard terms. And I might want to have the head of the queue. I could say top as well. That would be perfectly fine as well, Kylie. So very nice. Different terms for different things. I like saying NQ, DQ, head, like the head of the list, of the head of the line, but you could call it pop, push, and top as well if you wanted to. The reason it looks that way for priority queues is because they're using the same data structure underneath. I think they're using a vector underneath no, they're not using a vector. They're using a doubly linked list underneath. Yeah. All of those standard template libraries are using a doubly linked list, and you're limiting what functions you can call on your doubly linked list. That's how they implement a queue. It's essentially just a simplified, by removing some of the options, it means it's more simplified, which means you don't screw it up, which is why we have queues. NQ is a term versus function. So an NQ you will insert it into your queue, and then it will sort your queue. Versus a normal queue, it's a lineup. The person comes in the back of the lineup. They're at the back of the lineup. They don't get to move up further ahead. Like a priority queue, you'll move the people in terms of priority. This is you're last in line. You're last in line. Priority queue is slightly different than a queue, because a priority queue is you put people in priority line, like in an emergency room, who is most in terms of emergency, and then you just pull the person off the front of the line each time. Yeah. So I'm going to use an NQ. So nice. All right.
No, what I mean by that is I actually tried to use onQ with the priority queue, and it doesn't exist. I had to use push.
It will not exist because it's using the functions that are from the doubly linked list that it's being used to implement it.
Okay.
And so yeah, NQ, what is it, add or it's push?
It's push. It was push, pop, and top. So
it's literally push, pop, and top for a priority queue.
Yep. And I looked it up extensively to make sure I wasn't like looking at the wrong sources, but like I couldn't find, the only place I could find like onQ anywhere was just for a queue.
Yeah. I'm surprised, but
but everything priority queue was the same things as the stack.
Yeah, because it's same thing as a stack because they're both using a doubly linked list under the hood. Or are they using a doubly linked list? They might be using just an array, and a vector is also based on it. The point of that, though, and what I'd like that as a takeaway, it's not that I don't know things. It's I don't want to know these things. At a certain point in time, your brain's going to explode. So the key is just figuring out just enough, right? That you use somebody else's tools. I don't want to know how my drill works. I want to use the drill. Sometimes you want to know how something works, but sometimes I just want a tool. A priority queue from the standard template library, it's a tool. Great. You should practice using some of those tools. And now we're going to practice making some of our own things. It's a different thing, but it's so you can see the compare and contrast different things, different approaches. If you want, I can go push pop and top. If you want, I'm more than happy to here. I just like NQ and DQ, and I'm just a creature of habit, I guess. So what does this return? Well, DQ is going to do this, right? QUE. It spits out some piece of data. And void ENQUEUE. Maybe you guys don't want to write this because it takes a lot of typing. To add, this is what we're going to put onto this thing. And then head of the queue. All right. So I might want to have something about, there are two different things I could do here. I could also get maybe the size. The size is empty, maybe. Boolean. Okay, these are the functions I'm going to be plopping in there. And let me include all right. I'm also going to need to include, because I know what I'm going to be trying to get into, linked list. All right. All right, and I'm going to be lazy, and I'm going to just copy this whole thing over, and I'm going to, so let's save that. Where's my queue hit? And lazy, there we go. I'm not sure if it's a good habit I learned from my former boss or a really bad habit. He just copied and pasted everything. Even if it took him 2 seconds to type it, he'd copy and paste just to, he'd spend 4 minutes copying and pasting rather than 2 minutes to write it. It was really over the top with that sort of thing. Okay. All right. So now what do I have? I have this queue. What's wrong with this? Invalid destructor declared. Yeah, missing those. All right. So maybe what I want to do for my queue is maybe I want to make a linked list. I should have a linked list automatically, right? So I don't even think I need that destructor and constructor. I'm going to put, cout statements or something like that. I don't think I even needed the constructors and destructors in this case. Okay, I'm going to copy that. Because I'm lazy. Okay, save it. All right. DQ, what's DQ going to do? DQing it is going to be removing from the front, right? So if I add from the back, I remove from the front. Well, let's actually look at my link. I could also do it the other way around, right? I could add to the front, remove from the back. It's the same thing. As I add new elements, I can remove from the back, or I can add from the elements this way and remove from the front. It doesn't matter. It's going to be the exact same thing. In fact, I don't even need to use a linked list. My queue could actually be using an array and just hiding all of that information. That's the point of object-oriented programming, is that I want to use a queue. When I've made this and I've tested it, I pass it to somebody else and they're blissfully unaware of how the heck this actually operates. So let's look at my linked list class and get next. I can find things. I have a remove in here. I have get previous, get last, find. Do I have something to add to the? Oh, these are my public methods. Sorry. Here's add. I'm going to add it, and it's going to go to the end of my queue, and it's being added there, right? Sorry, linked list. Right, that's what add does, or at least from what I'm seeing here. I make a new node. If it's not a head, let me see here. I get the tail, and I add it to the tail. So I add to the very last element of my linked list. So add is done. NQ would be fine. Remove looks for a particular element. When it finds that particular element, it removes it. I can get the size, that's fine. I can get a particular index, that's fine. Actually, that might do it for me. I just get index 0 each time. Print list, okay. So I want to figure out what my linked list has available to me. And I'm just going to try and use those tools. So what are my tools available? So my DQ, I want to remove a particular element. Oh, I needed to remove. I'm adding to the end. I want to remove from the front. I don't have, I can get, let's try, maybe we can do this easier way. Okay, so what's DQ going to do? Well, first of all, I need to see if this thing is empty or not. If, I might want to do some kind of assert or something like that. Just in case you thought I was giving up on asserts for a second. No, they're back. I want things to blow up in my face if, oh, it's this kind. All right. Assert and is empty. I want to say it's not empty. If I try and DQ an empty queue, what happens? Well, it's saying I have to return a value here. Maybe I don't have to return the value. Maybe we could just remove the value. But if I'm saying I'm returning a value and there's no value to return, what's an empty linked list data node? I can't make one. I don't know if it's empty or not. I want this, unless I have a pointer or something like that, I sort of need this thing to blow up. You're saying, give me the last, the top tray, and there's no trays there. What do you do? Right? You can't pass the person anything. So you're have your hand out, give me the tray, and there's no tray there. Or that tray's not a good example because we're talking about stacks in that case. If I'm asking for something like asking to remove the last element or the front of the queue, and there's no front of the queue, it's completely empty. What do? You can't do anything. So you sort of want to test beforehand, is it empty? If it's not empty, then you call DQ. That's what you would normally have in your actual code. Or the person using the queue. You can't just call DQ if there's nothing there. Okay. So I'm just going to say, no, you can't call this thing if it's empty. So it's not empty, I want to get I can say find, I do believe, I can get the individual element, and I can remove that individual element. Okay, so get index at 0, and this is, so that's a T, so it's a linked list data node. Okay, the value at the head. Okay, and then I'm going to list.remove, and I'm going to head value, and I can make sure that it gets properly removed, but that's fine. So I could say oh what? I actually am not. There's nothing I can do about it if it doesn't get removed correctly. So let's just leave that alone. I'm just going to take the plunge here and say I have the head value. I've removed it from the head. So I'm going to return head val, and that's it. In fact, I could actually do this right here. I can get the head value from, so I can't call this any other way. If I ask for the head of the cube and there's nothing in there, it should blow up in my face as well. And then I have a remove here, but I don't really need the remove. I can return head value. Okay. So I could, instead of this, well, I'll leave it at that. I'll leave it like this. I am checking to see if it's empty. I'm getting the very head of the cube, position 0, the first element in my linked list. And then I just return it. This, by the way, head, notice it doesn't change my linked list. It just says what's at the head of the queue. It doesn't say that that I've removed it. Let's do NQ. What's NQ? So I can do list.add and then to add, and that's it. That's all I need. Seriously. And is empty. Okay, I can say list.get size. Is it empty? Well, I can say, is it equal to 0? If it's equal to 0, it's empty. Otherwise, it's not empty. Great. And now let's start adding some stuff. Let's test this. So I'm going to add my linked list queue. Actually, it should automatically, I'll include it anyways. QUEE 2400. All right. Let's make some other stuff. Okay, so I just let the letter Q. And let's leave it alone like that. And then give me some numbers to add to it. Oh, actually, I need particular numbers here, don't I? I need these kinds of things right here, but linked list data, right here. So someone give me a number. You can microphone it or just any old number. Integer, sorry. You can't be, unless you tell me, smiley face or question mark, you really can't be wrong. Okay, thank you. Come on, it's a bit of participation. It's fine. All right, what other things do we have? So is there a problem with this? That should be fine. What other number? Give me another number, maybe. And I'm going to have to see what the heck's going on with this. Oh, 15, great. And maybe one more. I know what I have as a problem here, so hold on a second. Give me the next number and then we'll fix what my error is here. 22, great. All right, so I've added 3 numbers. Let's remove one of those numbers, DQUE, and it's just going to return the front of it. And then I'm going to maybe mince, and let's see, Q dot. Okay, and this is me hard coding some values in to see what it's going to look like. Okay, we have a problem with this thing here. I got to figure out what the heck is going on here. So I'm going to go over to Q2400, and that's my issue. Notice what the error was. It's inaccessible. which reeks of I don't have access to it. It's protected or it's private or something. So okay, and then we'll see what's going on here. DQUE. This returns, oh, it returns an LL data and then get value. All right. And this one's going to get value as well. So what would, before I run it, what do I expect? I expect a constructor when that queue gets created. I expect it when I add I'm going to add 3 numbers to my queue. I'm going to remove 1 number without putting it out. That's what this DQ is going to do. And then I'm going to call cout, which is going to remove the next 2 numbers. So I should have an empty queue at the end. Heck, I can even assert this. Assert, and then queue dot is empty. I'm going to assert that it's empty afterwards. I put in 3 things. That's what I would expect. It should be empty by now. And I've called DQ twice, but that returns the value that was at the head. And so I can get the value here and spit it out. So let's find out. I don't know if it's going to work. I'm pretty sure I know it's going to work, but still, you never know. And okay, let's run it and see what happens. Boom. Okay, let's see what we have here. This did a whole bunch of other stuff in here. Deleting. Oh, these are the deleting nodes. Okay, the queue was destroyed. That's my destructor. Here's my queue with 2 elements in it, 22 and 15. I made my queue. I deleted 1 element already. I added 3 elements. I deleted 1 of the elements. Then I did a print statement that put out the other 2 elements. It is now an empty queue. The assertion doesn't get called. And when I'm done my main method, I destroy the queue, I destroy this linked list, and I destroy this linked list because I'm done my main method. And these are static variables. These are static objects. And so I do all that cleanup and now I'm done. So I can test my code. If I wanted to, I could also test it to, I could have it spit out what the head is here and here and here. Oh, let's do that actually. Let's do that. So Q head is, and then I'm not going to DQ it. I'm just going to call head on this thing and get the value. Standard. And what would you expect? That's the next step every time, right? I've done some coding. What do I expect? I have this kind of test. What do I expect? Don't move on until you've actually tested, I know what I want to test. I want to see what happens if I'm going to add an element, see what the head looks like, add another element, see what the head looks like, add another element, see what the head looks like. What's going to happen here? Is the head going to change? Let's see what you think. No, it won't change. Nice. Thanks, AJ. That's exactly right. The head's not going to change. It's a queue. If people line up behind me, I don't care. Until I get through that turnstile, who cares who's behind me, right? I'm at the head of the line. I'm not moving until I get in. So you would expect to see no change here. Let's roll it. And we may have this, we get this weird issue with cout statements for some reason in Visual Studio nowadays. Okay, the head is 9, the head is 9, the head is 9. I removed it. Now the elements are 22 and 15. Then it's destroyed. I tested it. I made sure it works. Then I can move on. I can test it other ways too, but. Oh, thank you. Let me see if I can get the output. Thank you. Screen sharing. I'm going to stop my screen sharing. I'm going to do a new screen share. And I'm just going to do the whole screen. There you go. Hopefully that's better. So thank you. Here's what I had. What I had before was this. then I destroy the queue, and then I destroy the linked list afterwards, right? Because they're all static objects. I made my queue, but for my queue, I made my queue. I said something about the head each time, every time I added a new element. I removed the element 9. I then called that, saying what else was in the queue for the next 2 elements. And then I destroyed it afterwards. If I wanted to print out the queue, I could either, there's a bunch of different things I could do. I could remove the head and stick and enqueue it immediately afterwards. So pull off the first element, put it at the back, pull off the next element, put it at the back. And every time I pull off an element, I print off the value. And that's one way of actually printing off all the elements in a queue. I just need to find out when I stop, which is actually the challenge. Or I could just ask the linked list, hey, linked list, what's at element 0? What's at position 0, 1, 2, 3, 4? All right. Is that making some semblance of sense? Now the question is, can I template that? And the answer is yes, of course, hopefully. Hopefully that's the obvious answer, but I want to make sure I'm doing it right. So what I do is for each one of these parts, I just put in what I had over here into Q2400.h. So instead of this, it's whatever I had in there. I'll also need to, by the way, I need to move up that assert to the other one. And I probably should put that a line above. Out of convention, you always do your library files first and then your local files. Okay. So it'd be something like that. And then it would be something like this. Actually, I want to just, I'm not going to permanently do it for you guys because I'm going to just leave it as an exercise if you want to do it. This itself is in, let me see if I have the right, you probably can see what the project is. It's being covered up right now. Oh, L15 simpler LL template. This is in the shared code repository. So you can actually look at this anytime you want. It should be readily available to you guys. What you can do as an exercise is see what you would do to template this thing. I need to make sure that I have, where is it now? This thing right up here. The class is templated using some template type T. And everywhere I have in here, every time I talk about, let me see here, LL data here, LL data here, LL data here. Everywhere I see that, I just put in a T. That's it. That's the entirety of templating the class. And so you can give that a try because we're going to run out of time here. Just to make sure you feel comfortable with templating the class. Maybe make a stack. That's a perfectly fine thing. Maybe make a priority queue for yourself. A bit harder to do because then now you need to know where it gets inserted. If you do it inserting as you go. Make sure you know how sorting algorithms work. I'm not going to ask you to implement quicksort, but I can ask, how does quicksort work? Right? So last term I said, here's an array of elements. Quicksort is being applied to it. What does the code look like at the next step? What does the code look like? Or what does the array look at the next step? What does the array look like at the next step? And it wasn't like this formalized, oh, it has to look exactly like this. It's like, what does quicksort do? It takes a pivot point. It sorts things based on the pivot point. What does insertion sort do? What does insertion sort do? Yes, it takes off the first element, whatever it is, puts it into a destination array. Takes out the second element, puts it in the right position in the destination array. Takes out the third element, puts it in the correct destination position in the destination array. I just keep on pulling it off one after another in the old array, putting it into slotting it into the correct sorted position in this new array. Selection sort, find the minimum, pull it off, but find the next minimum, pull it off, find the next minimum, pull it off, putting into a new array. These are the kinds of things that you want to just, if there's a topic that didn't make sense when you go through all of this, take a second. Well, you can also ask questions. Take some time, make sure you understand what's going on and how it actually works. You won't be asked to memorize how linked lists work, but you should know how they operate, right? I can add things to my linked list. I can insert things in my linked list. I can remove things. I can see how long my linked list is. You should know how a queue operates or what a hash table is, what a hash function is. If that's confusing, ask questions. Okay, so I'm going to remove this thing here. I don't want to just give away what we're doing here. But if you can do that, you're probably pretty good when it comes to templating. It's a matter of just moving from this to this. And you'll notice my approach is I write it the slow way, or the slow way, the way with a CPP and a header file. And then I migrate everything over when I know the code is actually working then. Because I don't want to be trying to write everything as a template. It's too hard. Or at least I find it too hard. All right. Can I answer any questions? It's 5:11 right now. I'm thinking my kids want to eat some lasagna. How many of you are asleep? Type if you're asleep. Now, all right. At the moment. That's fine. Wait, I'll wait, Callie. It's okay. I was joking. It's like, that classic old dad joke. Anyone that's not here, speak up. That's yeah. I'm an old dad now. I have to make old dad jokes. Printing a duplicated array. So what do you mean by printing a duplicated array? It's if I duplicate the array, it's just printing off an array. You pass in a different array, it prints it off. So it doesn't, once I've duplicated it, I pass in the same print array function, let's say. And no matter what array you give it, it just prints off the elements of that array. What I should also do, AJ, though, is I'll make sure that I pass off the assignments. Now that assignment 6 is done, I want to make sure you guys have the solution file for assignment 6 as well. And you'll see what that code looks like. Although I can, hopefully. Yeah, it's as in I make an equivalent sized array, copy the same things over to like duplicate it all in the other one. So if there's a 3 over here, I put a 3 over here. If there's a 4 over here, I put a 4 over here. I just copy all the elements over and then print it off. And the printing is you pass it the other array and it still prints it off just fine. Where it was doing something weird. It was printing the first 5 values perfectly, and then the rest was just random values. Like, it's not a random value in that case. That's a great question. This is also why we did 2's complement, by the way. That's probably a -1. It may not be. It might be CD, 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 or C, 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 C in hex, meaning you didn't initialize the value. So you made an array. You didn't copy all the variables over. You only got to the first 5. And now you're continuing on. So your copying over function probably only did the first 5 and then stopped. I would actually put a breakpoint when you're doing the copying over to make sure it's copying over for all the values, because I think it's stopping early for you. And that's what the problem was. It's the generation of, or the copying over the new array. Nice. I'll make sure that you have A6 available to you because the code's there. I have it available so I can pass it off to you guys. All right. Does that answer most of your burning questions? I will take that silence as an answer. All right, no problem. That's what I'm here for. All right. So with that, what I might do is I'm hoping to actually see if I can do another, makeup session or review session before the exam, which is 16th, I do believe. So, a couple of days before, when people have actually had time to study, right? Then you'll have more burning questions and we can go over some topics that you find confusing. All right. All right. Thanks, everyone. I will talk to you soon then. Nice. All right. Thanks.